Consider an inclined plane that makes an angle alpha equal 30 degrees with the horizontal plane. An object taken as a particle of mass equals 0.5 kilograms is launched at time 0 from the bottom O of the inclined plane with a velocity vector v0 equal v0i. A is a point on OB and OA equals 5 meters. The position of S at an instant t is given by OM equals xi, where x equals f of t, or is a function of time t. Take the horizontal plane passing through OH as a gravitational potential energy reference and use G equals 10 meters per second squared.
The mechanical energy of the system S Earth as a function of x is represented by the graph of figure 2. Use the graph in order to show that object S is subjected to a friction force between the points of abscissas 0 and 5 meters. Look at the graph. For abscissa 0, the mechanical energy is 25 joules, and for abscissa 5 meters, the mechanical energy is 15 joules. Then, the mechanical energy decreases with abscissa. We know that the work done by the friction force results in a decrease in the mechanical energy. Then, S is subjected to a friction force.
BI. Calculate the variation of the mechanical energy of the system S Earth between O and A. Look at the graph. For x equals 5 meters, the mechanical energy equals 15 joules, and for x equals 0, the mechanical energy equals 25. So ME5 minus ME at O equals 15 minus 25 equals minus 10 joules. Deduce the magnitude of the force of friction supposed constant between O and A. We know that the variation in the mechanical energy equals the sum of the work done by the non-conservative forces in the system. But the friction force is the only non-conservative force that does a work, so delta ME can be written as the work done by the friction, and the work done by the friction equals minus F times OA. Replace delta ME by minus 10 and replace OA by 5. Therefore, the magnitude of the friction force equals 2 newtons.
Let's move to part C. Determine for x greater or equal 0 and less or equal 5 meters the expression of the mechanical energy of the system S Earth as a function of x. Look at the graph. Between abscissa 0 and abscissa 5 meters, the curve of ME is a straight line. Then its equation is ME equals AX plus B, where A and B are constants. Now let's calculate the values of A and B. Let's start with A. A is the slope, and it is equal to delta ME over delta X. Now, in order to calculate the slope, you can choose any 2 points on the curve. So let's choose the first point and the final point. Between abscissa 0 and abscissa 5 meters, the mechanical energy decreases from 25 to 15 joules. And between abscissa 0 and abscissa 5 meters, the abscissa increases from 0 to 5 meters. Then the slope equals minus 2 joules per meter. Now let's calculate the value of B. Look at the graph. For abscissa 0, the mechanical energy is 25 joules. Then B equals 25 joules. Now replace A and B by their values in the first equation. You will get ME equals minus 2x plus 25. And this equation is expressed in SI units. This equation is the equation of the straight line of the mechanical energy between abscissa 0 and abscissa 5 meters.
Part D. Determine the speed of S at the point whose abscissa is x equals 6 meters. To determine the speed, we use the expression of the mechanical energy. ME equals KE plus GPE, which equals 1 half mv squared plus mgh. H is the altitude of this point relative to the reference level of gravitational potential energy. Look at this figure. In the right-angled triangle, sine alpha equals h over x, then h equals x sine alpha. Alpha equals 30 degrees, so h equals 6 times 0.5 equals 3 meters. But for x equals 6 meters, the mechanical energy equals 15 joules. So replace me by 15 and replace m by 0.5, replace g by 10, then the speed for x equals 6 meters is 0 meter per second.
Let's move to part 2. Let v be the speed of s when it passes through point M of abscissa x, where x is greater or equal to 0 and less or equal to 5 meters. Now we want to determine the relation between v and x. The general expression of the mechanical energy is 1 half mv squared plus mgh. In the previous slide, we have seen that h equals x sine alpha. So let's replace h by x sine alpha. You will get this equation. Also, in the previous slide, we have seen that the expression of the mechanical energy as a function of x is minus 2x plus 25. So let's replace me by minus 2x plus 25. And we replace m by 0.5 kilograms and g by 10 and sine alpha by 0.5. Now we have a relation between x and v. 0 equals 0.25 v squared plus 4.5x minus 25.
Focus, please. This is important.
Part B. Deduce that the value of the acceleration of s is a equals minus 9 meters per second squared. Differentiate the above equation with respect to time. The derivative of 0.25 v squared equals 0.25 times 2v prime. The derivative of 4.5x with respect to time equals 4.5x prime. And the derivative of minus 25 equals 0. Now multiply 0.25 by 2, we get this new equation. We know that v prime equals a and x prime equals v, so we write this new equation. Take v as a common factor, then v into 0.5a plus 4.5 equals 0. But v equals 0 as a solution is rejected. Therefore, 0.5a plus 4.5 equals 0, then a equals minus 9 meters per second squared.
Let's move to part 3a. Determine the values of the speed of s at O and at A. Let's start with point O. The mechanical energy at this point is the sum of the kinetic energy and the gravitational potential energy. Look at figure 1. Point O is the origin of the x-axis, then xO equals 0. And when S is at O, then it is at the reference level of gravitational potential energy. Then GPE at point O equals 0. Now look at the graph. When the abscissa is 0, the mechanical energy is 25 joules. Then replace the mechanical energy at point O by 25 joules. Now replace the kinetic energy at point O by 1 half mvo squared. Replace m by 0.5 kilograms. Then the speed at point O is 10 meters per second.
Now, let's determine the mechanical energy at the point A. MEA equals KE at A plus GP at A, which equals 1 half MVA squared plus MGHA. Look at figure 1. HA equals sine alpha times OA equals 5 times 0.5 equals 2.5 meters. Look at figure 2. For x equals 5 meters, the mechanical energy equals 15 joules. So replace MEA by 15, M by 0.5, G by 10, and HA by 2.5. Therefore, the speed of S at point A equals 3.16 meters per second.
Let's move to part B. Calculate the duration of the displacement of S from O to A. Given that V equals AT plus V0, this equation can be used for rectilinear motion with constant acceleration, where V0 is the initial velocity and V is the final velocity. So, the final velocity is VA and the initial velocity is VO. Now replace VA, VO, and the acceleration by their values. We will get T equals 0.76 seconds. So it takes us 0.76 seconds to move from O to A. Let's move to part C. Determine the linear momenta PO and PA of S at O and at A respectively. Let's start with PO. PO equals MVO. Now we have the speed at point O. It is equal to 10 meters per second. But what is the velocity at point O? Look at the figure. S is moving along the positive x direction, then V0 equals plus 10I. Therefore, PO equals 5I, and it is expressed in SI units in kilograms meters per second. Let's move to PA. Similarly, the object S is moving along the positive x direction, then the velocity at point A is plus 3.16 I. Then, the linear momentum at point A is 1.58 I.
Part 4. Determine the resultant of all the external forces acting on S, and then verify by using the previous results. Newton's second law. Use delta P by delta T equals dP by dt. Consider the motion of S between O and A. The external forces acting on S are its weight mg, the normal reaction N, and the friction force F. So the sum of these forces equals mg plus N plus F. Project these forces along the positive x direction. The projection of the weight equals minus mg sine alpha. The projection of N equals 0, and the projection of the friction equals minus F. Now, replace M by 0.5, sine alpha by 0.5, G by 10, and F by 2. Therefore, the algebraic value of the net force equals minus 4.5 in newtons, and the net force vector equals minus 4.5 I expressed in newtons. Between O and A, delta P by delta T equals PA minus PO over delta T. PA equals 1.58 I and PO equals 5I. Therefore, delta P by delta T equals 1.58 I minus 5I over delta T, which equals 0.76. Therefore, delta P by delta T equals minus 4.5 I. So, the sum or the resultant of all the external forces equals delta P by delta T, which equals to dP by dt. Therefore, Newton's second law is verified.